We could then use some of these values to determine exact values here because we know that sine is the y-coordinate with respect to an angle and cosine is the x-coordinate with respect to an angle. So if I wanted to find sine of 120 degrees, well, I can just go up here, look at sine, which is 120, and I can see, oh, the sine is the y value, so that's root 3 over 2. And that's where the unit circle becomes a really valuable tool, because it's almost like it's doing the work as a calculator for you. You can also find sine of 120 without using a unit circle by using the reference angles that we just looked at on assignment number 3. So all you'd have to do for that, you don't have to know what a unit circle is. You don't need to look it up. All you can do with that is say, okay, well, where's 120? Well, I know that's 90. 120 is just 30 more. So that's 120. Well, what's the reference angle to that? Well, the reference angle to 120 is the difference between 120 and 180, which is 60. Because I know that 180 minus 120 is 60. But I know, oh, if this is 60 degrees, this is a right triangle. That's 30 degrees. I now have a special right triangle. And I know this is a special right triangle with a side length of 2, 1, and root 3. Where the opposite of 30 is 1, the hypotenuse is 2, and the adjacent to the 30-degree angle, the opposite to the 60 is root 3. In which case, I can say, oh, okay, I can find out what sine of 120 is. I just need to make sure that when I label these, this isn't just 1, I'm going back 1 and up root 3. Which in sine isn't going to matter because sine of 120 is the same as sine of 60, which is root 3 over 2. Notice it's the same exact thing I got here, but I didn't need to have a unit circle. I could also do cosine of 120, where the value, the negative value of on the x-axis matters because cosine is now negative 1 over 2.